بسم الله الرحمن الرحيم. We discussed the multiplication rule of the probabilities, and we said that two events are said to be independent if choosing A is not affecting the probability of choosing B. If it does affect the probability of the second event, we say these are dependent. This time we are going to speak about the conditional probability, this is also a part of the multiplication rule of the probabilities. The probability that the second event be occurred given that the first event A has occurred can be found by dividing the probability that both events occurred by the probability. And we say the conditional probability is given by this formula, P of B given A. We say this is find the probability of the second event given that the first event already happened. So P of B slash A means after the first event has occurred, we need to find the probability of the second one. So we have one condition here, that the first event is already happened, is equal to B of A and B divided by P of A. This is the conditional probability. Find the probability of the second event given that the first event is already occurred. Just explain this in detail by the following example. Final result of section shows that 80% students or 8% students are A plus in mathematics. 2% are A plus in mathematics as well as in English. If one student is chosen at random, find the motive that he got A plus in English when he is A plus in math. You see, now I have to decide which one is the first event and which one is the second one. Now this is the question, find the probability that he got A plus when he got A plus in math. So it means that he got A plus in English after he got A plus in math. So A, the first one, first event, A is getting A plus in math. Second one, it is B is getting A plus in English. So I need to find P of B given A. Means find the probability of getting A plus after he got A plus in math. And by the rule, this is B of A and B divided by probability of A. Now getting A and B means getting A plus in math and getting A plus in English. It is 2%. So getting A plus A and B means getting A plus in math and A plus in English, which is given there in the question. 2% are A plus in mathematics as well as in English. So this is 2%. Divided by P of A. P of A means getting A plus in math. Getting A in math, it was given in the question 80%. So this is 2/8, which is equal to 1/4. So this is the idea of the conditional probability. Find the probability of the second event, given that the first one is already happened. Let's take another example. Say in JIC, 35% in some college, 35% students failed in mathematics, 25% students failed in physics, and 10% students failed in both the subjects. If one student is picked randomly, then find the probability that a student failed in mathematics if he has failed in physics subject. So you can see that from this question, the first event A, C, if he has failed in physics. So the first event is failed in physics. Second one, B, failed in math. And from the question we know, it is B of A, which is failed in physics, 25%. B of B, 35%. B of A and B is 10%. Failed in both physics and math. They failed in physics and math is 10% of the students. We need to find a student. He failed in math after he failed in physics. If he has failed in physics. So we need to find B of, let me call it B, which is failed in math after he failed in physics, is equal to, by the rule, it is B of A and B divided by B of A. Okay, so this one. Usually, always the second one will be down. Now getting failed in both of them is 10%. Divided by failed in physics is 25. So this is divided by 5. I will get 2 out of 5. So the percent of getting one student failed in math if he failed in physics is 2/5, which is 0.8% or 80%. Sorry, 40%. 2 divided by 5 equal to 40%. So this is the idea of conditional probability. One more. A box contains black chips and white chips. A person selects 2 chips without replacement. If the probability of selecting a black chip and a white chip is 15/56, and the probability of selecting a black chip on the first draw is 3/8, find the probability of selecting the white chip on the second draw, given that the first chip was black chip. So let's say I have A or first event select black chip. So this is A. So B of A in this case given 3 out of 8. Now second event B select white chip. Now A and B we're selecting black and white is given 15 over 56. So the probability of getting white after getting black. So we need to find the probability of selecting the white in the second after we getting black in the first choice or selection. It will be B of A and B divided by B of A, which is equal to B of A and B is 15 over 56, and B of A is 3 over 8. So this will be 15 over 56 divided by 3 over 8. Which is equal to, this is because we have two fractions, it will be 15 over 56 multiplied by 8 over 3, which is, if I can just simplify, I will have 7. 3 with 15 is 5, so it is 5 over 7. So the answer is 5 over 7. Direct application for the rule of the conditional probability. Let's see this example. A recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are given in this table. 32 males say yes, and 18 said no. For the female, 8 females said yes, and 42 said no. So the total of the males we have is 50. Just add these two, 32 plus 18 equal to 50, and also we have 50 females who said yes. We have 40 who said no, 60. The total of these two is 100, but it's given there. Now we need to find the probabilities of the respondent answered yes, given that the respondent was a female. Now the two events are yes and female. So the questions say find Y getting female. So I need to find the probability of getting yes, given that who said yes is a female. So this is equal to B of saying yes and female divided by probability of female. This is conditional probability. I need to find yes in the second. So when he said given that the respondent was a female, so this is the first event. This is the second. So it is P of Y given female equal to P of Y and female, means female and said yes, divided by the motive of the female in the forces. So this is equal to who said, or female who said yes, female and yes. This is yes and this is female. There are 8. So we have 8 out of 100. We have 100 people there and 8 females said yes. And out of the 100 we have 50 females out of 100. So the answer will be cancel these two, just simplify it. This will cancel this one. It is 8 over 50. Or it is divided by 2, 4 out of 25. So the probability of getting yes, given that the respondent was a female, is 4 out of 25. Second one, the respondent was a male, given that the respondent answered no. So I have, now this is a, given that means this is the first, and this is the second. So I need to find B of male given no. So this is B of male and said no divided by probability of the people who said no. You see how many males said no? Male and no, it is this one, 18. And we have 60 people said no. So this is equal to 18 over 100 divided by 60 people said no out of 100. So simplify this one and say this one. I will have 18 over 16 or 60 divided by 3 or 1, just by 3. It will be 6 out of 20 or 33 divided by 6. It will be 3 out of 10. So it is a 3 out of 10, or I can say just 30%. 3 out of 10. So this is the idea of the conditional probability. Find the probability of the second event given that the first event has already happened. So it is a B of A and B divided by the probability of the first event. First event should be in the denominator in the rule. So the probability of the second given the first equal to the probability of the first and second divided by the probability of the first one. And in our example here, we have a 3 out of 10, or it's equal to 30%.